Okay, this is lesson 1.3, Advanced Math Notes 1.3, Unit 1, Day 3, or Unit 1, Lesson 3. Alright, so let's start to label. This is 1.3. We're going to label it Rational Expressions. Rational expressions. All right, part 1, reducing. All right, simplify. And this is review from your last year's math class, again with some harder ones added in. B to the third plus 1 all over 3b to the third minus 2b squared minus 3b plus 2. So when you see a problem like this, what you want to look at first is remember and recognize that I cannot reduce individual pieces. I cannot reduce these b cubes because they're held together with plus and minus signs. They're pieces of a polynomial, and you cannot break apart and reduce pieces of a polynomial. So you have to factor first and then reduce. So remember that you'll have to factor first before you try to reduce. So take a look at the top, b cubed plus 1. I'm hoping you recognize that it is SOAP factoring. Take a look, let's write that down. SOAP, which is the cube factoring. And we call it SOAP because of the same opposite, always positive. And if you look down here, you'll see that there are 4 terms. And 4 terms implies factor by grouping. Now when I do factor by grouping with problems like this, I typically try to do a 2 by 2 first. So that's where I'm going to start. So hit pause, factor them on your own, and then press play and see if you did it correctly. All right, this is what you should have. A is B and B is 1. So there's your A, your B, A squared, AB, and B squared. Same, opposite, always positive. Now on the bottom I have, oh, and this does not factor anymore. When you factor by grouping, if you have done the GCF first, which there is no GCF, you won't be able to factor any further. But down here, recognize that I'm not done. You may think, well, there's nothing to cross out, and that's because I'm not done factoring here. Factor by grouping has 2 steps, and I am not done. All I've done is the GCF on the first chunk and the GCF on the second chunk, but I have not fully, completely factored the factor by grouping piece. So with that being said, oh, before I go further, recognizing right here when I took out the b squared, that's pretty self, like you can see that there. Here though, what did I take out? Since there's nothing in common, you would either take out a positive 1 or a negative 1. Since this is a minus sign, I'm taking out a negative 1. Negative 1 times 3b is negative 3b. Negative 1 times negative 2 is plus 2. Alright, so then I have b plus 1, b squared minus b plus 1, and don't forget, if you have questions, you make notes to yourself to ask me tomorrow in class. Here my GCF is the 3b minus 2, not squared because there's only 1 in the first term and 1 in the second term. There's only 1 common factor in each term. That leaves me with b squared minus 1. Now I'm hoping you look here and saying, I can still factor. Can everybody see that this second piece right here, the b squared minus 1, is still factorable? Difference of 2 squares. So b plus 1, b squared minus b plus 1, 3b minus 2 stays, and what does the second piece factor to? B plus 1 and b minus 1. All right, then at this part is where we look to see if there is anything to reduce. And really it looks like there's only one piece to reduce, and that's this right here, b plus 1 and b plus 1. Nothing else does reduce, and like I said earlier, this factors no further. So this is it. What we're left with is pretty much our answer. So b squared minus b plus 1 in the numerator, and in the denominator 3b minus 2, and then b minus 1. And that there is your final answer. All right, number 2. Don't forget you can hit pause along the notes if I'm going too fast. C plus 3 squared minus c plus 2 quantity squared all over 4c squared plus 20c plus 25. Okay, so what kind of factoring do we have? In the numerator, you have a difference of two squares. Can you see that? Perfect squared, minus sign, and there's two terms. And then down here is the trinomial guess and check. I'm going to start you off. This is where you use the big exaggerated parentheses, and then you will have some smaller parentheses inside, plus and minus. And then the bottom is simply a double bubble. All right, press pause, factor, and press play and see if you got it correctly. See if you did it correctly. All right, this is what I have. C plus 3 times C plus 3 is a C plus 3 quantity squared. C plus 2 is this piece quantity squared, plus minus, that's the way difference of two squares factors. This is a perfect square trinomial because 2c times 2c is 4c squared. 5 times 5 is 25. And when you check, this is 10c and that is 10c, which adds up to the 20c. We're not quite ready yet to cross things out because I still have to. I can't leave these nested parentheses up here. We talked about that the other day. No nested parentheses. So distribute and drop the inner parentheses. There's nothing to distribute here. So C plus 3 plus C plus 2. Here there is a negative to distribute. So C plus 3 minus C minus 2. Minus C minus 2. And the bottom for now is simply staying the same. You can write it as quantity squared if you'd like to. That's up to you. I'm going to leave it as 2c plus 5 written down twice. Okay, now if you remember the other day in notes, I did tell you guys to combine like terms if possible. And this is a if possible situation. 1c plus 1c is 2c. 3 plus 2 is 5. That's my first piece. My second piece, I have c and negative c. That does cross out to 0. The c plus negative c, they cross out. Then I have 3 take away 2, and 3 take away 2 is 1. You do not have to write the times 1 there because 1 is the multiplicative identity. You do not have to write it. I'm only writing it so that you can see what happened here. All of this simply became 1. All right, 2c plus 5, 2c plus 5, and you can see that one set and one set only is crossing out here. 2c plus 5, 2c plus 5. That's the only piece that's crossing out. That does not leave me with the final answer of 2c plus 5. It is 1 over 2c plus 5. And even if you did not write that 1 there, you should still recognize that there is a 1 left at the top and 2c plus 5 left in the denominator. All right, that is it for part 1. Again, hit pause if you feel I'm going too fast. Part 2, adding and subtracting. Adding and subtracting. All right, number 1. 3 over a squared minus b squared plus 5 over a squared minus 2ab plus b squared. So I'm adding these two fractions together. Now, if you remember back to even elementary school, in elementary school you were taught in order to add or subtract fractions, you need to find a common denominator. All right, when adding and subtracting fractions, you need to find a common denominator. So, in order to find that, we need to factor first. Just like up above where I had factor first, that's the same thing we have to do here in order to find the common denominator. So I'm going to do that next. All right, difference of two squares. Hit pause and factor. All right, I have a plus b, a minus b for the difference of two squares. A minus b, a minus b. I know that these two signs have to be the same because that's the only way to multiply to a positive. The neighbor tells me that they are both negative because a negative b times a negative b does come out to be positive b squared, and negative 1ab and negative 1ab is indeed negative 2ab. All right, now if you remember from Math 3, or even back in elementary school, when you're looking for a common denominator, you multiply by what's missing. Okay, so we're going to go through this and figure out how to do it. So I'm going to write it down here. My common denominator is I look first to see what they have in common. They have an a minus b and an a minus b in common, so that's definitely part of my common denominator. A minus b is part of my common denominator. All right, I cover it, and I look for anything else that's in common. Again, I covered those two a minus b's because that's what I wrote down here for what they have in common. Is there anything else in common? There is not, so then you just write whatever's left. Whatever's left is another a minus b and then an a plus b. So another a minus b will make it squared, and then an a plus b. Now if you need to, you can rewind. I will say it one more time. You look first for what they have in common. They have an a minus b in common, so I cover that. And then what is left over, another a minus b, that's where the squared came from, and then an a plus b, which I wrote there. All right, and then I multiply by what's missing. All right, a plus b, a plus b, a minus b, I need it to be a minus b squared. So I'm going to multiply top and bottom by a minus b. Doing that is going to give me the a plus b, which is already there, and the two a minus b's is going to make the squared piece that I need here. So I distribute the 3, 3a minus 3b. All right, next piece over here, I have the two a minus b's, which is the squared piece. A minus b and a minus b is the a minus b quantity squared. What I'm missing is the a plus b. So I multiply top and bottom by a plus b. Why do I do that? Because I want it to be a minus b squared, a plus b. And I multiply top and bottom. So you go ahead and distribute the 5. That gives you 5a plus 5b. And now that the denominators are the same, I'm going to go ahead and rewrite it as one fraction. All right, so it's going to be a minus b quantity squared, because they have that in common. I'm sorry, I'm going to write this exactly as it is. A minus b quantity squared, a plus b, because that is the common denominator. All right, 3a minus 3b. Because it's a plus sign, I can simply write plus 5a plus 5b. Just keep in mind, if that was a minus sign, you would distribute your negative. All right, combine like terms. 3a and 5a give me 8a. Negative 3b and positive 5b gives me 2b. All over a minus b squared, a plus b. And then at this point, you factor to see if anything can be reduced. So I'm going to go ahead and factor that now. I can take a GCF out here. The GCF is 2. That leaves me with 4a plus b. And then this is already factored and doesn't factor any further. So a minus b quantity squared and a plus b. Now the important thing to recognize at this point is that nothing reduces. Do you see that? There is no common factor that can reduce. I have a 2, a 4a plus b, and the denominator an a minus b quantity squared and an a plus b. Nothing reduces, which means I could have stopped here. Now typically I don't. I typically will factor to see if anything does reduce. I just want to make sure that you are aware when you're taking a multiple choice test and you see this and you get this answer, but this is the answer that they give you, kids always freak out. No, it's wrong because they didn't factor all the way. When you're working with these type of problems, see how it didn't say factor anywhere here? We only factor if factoring allows us to reduce. Factoring is only necessary if factoring allows us to reduce. So I factored. Since it did not allow me to reduce, I'm okay if I left it this way. Typically I do it this way because I'm always double checking, but this is okay. This is not wrong, it's fine. It's totally up to you in which way you want to write it. Now, if I did factor out the 2, and let's say this was an a plus b and I was allowed to reduce, and you never did it, then it's wrong. Okay, so if factoring does allow you to reduce and you don't do it, it's wrong. In this case, since factoring did not allow me to reduce, it's okay to leave it in this form here. All right, we're going to move on. Number 2, 5 over 5 minus 2a minus 6 minus 12a all over 6a squared minus 17a plus 5. Go ahead and hit pause because we're going to factor each denominator to find the common denominator. This one doesn't factor, but the second one does. Before you factor, I just want to quickly refresh that up here. I'm not going to factor. I don't factor the numerators because I want to be able to combine like terms later. So I'm not going to have it in factored form. But go ahead and hit pause now so that you can factor that on your own. All right, 3a times 2a is 6a squared. Negative 1 times negative 5 is positive 5. We know the two signs have to be the same because it's a positive. The neighbor tells me that they are both negative. Negative 2a, negative 15a does indeed add up to the negative 17a. All right, where I want to focus the time on this problem is, because this does happen on the test. Right now you should put a little note to yourself. It does happen on the test. And here is where it's tricky. Looking for a common denominator. Right now there is nothing in common. Right now there's nothing in common. So you can go through and take all of it. Take the 5 minus 2a, the 3a minus 1, and the 2a minus 5, but it's going to end up quite a bit longer and difficult if you do it that way. What I'd like you to recognize, and what you need to get used to recognizing, is these two here. They have a special name. 5 minus 2a and 2a minus 5 are called opposites. Why are they opposites? Do you see how this is positive 5 and over here it's negative 5? This is negative 2a and over here it's positive 2a. Those are opposites. For example, I'm going to cover everything but the 3a minus 1. What's the opposite of 3a minus 1? 1 minus 3a. So opposites flip on the negative. 5 minus 2a, 2a minus 5, and it does have to be a minus sign in order for that to work. All right, since they are opposites, I'm going to take the opposite of one of them so that they can be the same. Or factor out a negative is the way we're going to think of it. It doesn't matter which one you pick. I typically pick the one on the right because when I take out the negative, I can throw it right there in the middle. Let me show you what I mean. I'm going to factor out a negative 1 here. And I'm going to throw that negative 1 right in the middle. So this is what's going to happen. 5 is going to stay 5. 5 minus 2a is going to stay. That minus sign is now going to become a plus sign because that minus and the negative 1 that I'm factoring out from way over here, a minus and a minus become a plus. So if this was already a plus sign and you took out a negative, that plus sign would have become a minus sign. Minus and a minus is plus. If it was already a plus, it'd become a minus. Pretty much taking the opposite. All right, 6 minus 12a is staying. 3a minus 1 is staying. And when I take out the negative 1, what happens? The 2a becomes negative, so I'm going to put it at the end. The negative 5 becomes positive. I'm going to put that at the beginning. And boom, there we go. We have at least one common factor for the common denominator. Again, I took out the negative, made the negative 5 positive, the positive 2a negative, and now they match. And now we're ready to find a common denominator. All right, you take first what they have in common, and I'm hoping everybody recognizes they have the 5 minus 2a in common, not squared, because each term has only one factor of the 5 minus 2a. All right, cover it, and then you take what is left. What's left? The 3a minus 1. Don't forget, write questions if you have any to ask me tomorrow in class. All right, what do they have in common? 5 minus 2a. You cover it. What's left over? 3a minus 1. 5 minus 2a, what they had in common, the 3a minus 1 is what's left over. All right, and now we multiply by what's missing. On the first one, I have the 5 minus 2a. What's missing? The 3a minus 1. And I multiply it top and bottom so that 3a minus 1 times 5 minus 2a will indeed be this denominator here that I'm trying to get. Distribute the 5, 15a minus 5. Now if you look here and here, it's already the same. 5 minus 2a, 3a minus 1. So you don't really have to multiply by anything. If you'd like to think of it, you're multiplying by a 1, but really you're not changing anything. 6 minus 12a. Okay, so this is what I was saying earlier about the not factoring. Earlier I said kids are tempted to do a GCF here. You don't want to do a GCF here because right at this point, if you did a GCF, you wouldn't be able to combine like terms, which is what we're trying to do at this step. 15a minus 5 plus 6 minus 12a all over, and I can write it as one fraction now because the denominator is the same. 5 minus 2a 3a minus 1. All right, and again, this is where we try to combine like terms. So I have 15a and negative 12a, negative 5 and positive 6, which if I had factored out a GCF over here of 6, I would not have been able to do the like terms at this point. That's why we only factor the denominators and we save the numerators factoring until the end, after we combine like terms. All right, so what does that give me? 3a plus 1 over 5 minus 2a, 3a minus 1. Now taking a look, it's tempting to say, oh, these are opposites. These are not opposites. Positive 1 becomes negative 1 when you take the opposite, but 3a and positive 3, those are not opposites. So this is it. You can put parentheses there if that helps. It's not necessary, but you can write them. That's as far as you can go. You cannot reduce individual pieces. I can't reduce just the 3a's because I want to. I can only reduce whole factors. And these are not the same, so I am not allowed to reduce. All right, part 3, multiply and divide. Now, we are getting close on time to pushing these notes to the end, so I'm just going to do a multiply and a divide all in one problem. Let me show you what I mean. 5x plus 5y over 3x minus 27y times 7x plus 7y over x minus y, divide by 28x squared minus 28y squared over 27y minus 3x. Okay, now if you remember, again from elementary school, you can cross reduce when you are multiplying, and if you remember from last year, you cannot cross reduce bits and pieces just because you feel like it. You have to factor first and reduce factors. You cannot reduce individual pieces of a polynomial. All right, so I am going to do that first. If you'd like, you can press pause. I'm going to try to factor the numerator and denominator for these two fractions. All right, so this is what I have right now. I am going to go ahead and remind you that when dividing fractions, you multiply by the reciprocal. So I'm going to take this and flip it. And I'm going to do two things at one time. I'm going to flip and factor at the same time. So here I'm going to take a GCF out of as 3. That'll leave me with 9y minus x. Why am I putting it at the top? Because I'm multiplying by the reciprocal. All right, the top piece I can take out of 28. And I'm going to do this up here because I'm hoping some of you eventually can do this in your head. This piece right here, when you take out a 28, can you see that you're going to be left with x squared minus y squared? Can any of you kind of do that in your head ahead of time? Take out the 28 and then ask yourself, what's x squared minus y squared going to factor to? And you do it all in one step. X plus y, x minus y. If you do not like that, then do it step by step. 28, x squared minus y squared, and the next step you would do the difference of two squares. All right, with multiplying, I'm allowed to cross reduce, and I can cross reduce long distance. For example, like across this way, long distance if I choose. All right, so let's see if anything reduces. Okay, I can reduce these 3's first off. 3 is gone, 3 is gone. 7 and 28 I can reduce. 7 becomes 1, 28 becomes 4. I'm going to put parentheses around this x minus y. I cannot reduce this x minus y here because they're not diagonal. When they're horizontal like this, I cannot reduce them. The same is true with these two x plus y's, but I can reduce these two. Or these two, it doesn't matter how you think of it. All right, so x plus y is gone, x plus y is gone. It's getting really messy, so I'm just going to rewrite what I have and see if anything else reduces. So I'm left here with 5x plus y over x minus 9y. Everything's gone here except for a 1 over x minus y. And then 9y minus x over 4x minus y. Again, you do not have to rewrite it like this. It's just it was getting too messy up here, so I just chose to. All right, last bits and pieces of things that we can reduce. Taking a look right here and recognizing that we had a name for these earlier. 9y minus x and x minus 9y, what were they called? They were called opposites, positive x, negative 9y, positive 9y. Can you reduce opposites? Yes, you can. What happens when you reduce, for example, 5 divided by negative 5? What does that reduce to? Negative 1. Negative 3 over positive 3. If they are opposites, will they always reduce to negative 1? Yes. So when I reduce these opposites, gone and gone, I just put a negative out front. You can put that negative 1 anywhere you want. I put it out front because that's where I'm going to put it at the end. Where is that negative sign coming from is because I reduced these opposites. All right, so now I'm left with negative 5 x plus y over 4 x minus y quantity squared. Negative 5 because I reduced opposites, and then the 2x minus y's became the quantity squared. The 4 is there. Nothing else reduces because these again are not opposites. This is your final answer. And that is it for notes. Again, write your questions down so you have them ready for me beginning of class tomorrow.